Hi, everybody. This is section 7.2. And we're going to do confidence intervals when we know the population standard deviation. This is the setup for confidence interval. We did it last time. This part is the margin of error. This is the mean minus the margin of error. This is the mean plus the margin of error. Last time we also looked at the mean plus or minus the margin of error. And this is the margin of error, this whole thing here. The Z alpha over 2 was the confidence interval. The Z value for the confidence interval, 95%, the Z value was 1.96. And if you remember last time, we looked at how those were computed. And if you're going to do 90 here, this one's 95% confidence interval that we're looking at. So that means the middle 95% is shaded in. That means we still have 2.5% over here and 2.5% over here. So if we wanted to find the Z value for 2.5%, we can do that on our calculator, if you remember how we did that. And I'm gonna do that right now, if I can set up my calculator so you guys can see it. Let's turn this thing on. Oh God, really? I have a calculator where the batteries are dead. It's a rechargeable. It's a solar panel, but calculator. What happened? It's not turning on. And so I can't do that. Give me a second. Resume recording. All right, so we're going to now then use the TI Nspire to find how this Z equals 1.96. A confidence interval of 95%, the Z alpha over 2 equals 1.96. So I'm going to go to my calculator page and we're going to plug that in. Let me change it to that. And I'm going to stop sharing. And I'm going to flip this. Oh, there we go. And let me get my calculator back. There we go. All right, if we remember how to do that, we have to go, I'm going to add a calculator page. And then we have to go to, I'm going to grab my calculator first, menu 553. So if you remember, if you have the Z value, if you have the percentage, then you go to your calculator, hit menu 553. And once again, menu 553. And the area that we're going to do is 0.025. We want a 2.5% area, 2.5%. And then we have 0 for average and 1 for standard deviation. And when you hit enter, you get negative 1.959, which is negative 1.96. Negative 1.96. So when I come back here, once again, we wanted to find a Z value for this right here. And this was 2.5%. Since this was 95%, this is 2.5%. And this was 2.5%. So if I put 2.5%, 0.025 in my calculator on 552, it gave me a negative 1.96. And remember last time I said, yeah, this is the negative 1.96. But if you do the same thing over on this side, you get a positive 1.96. And when you do confidence interval, you always put the positive value there. So they know it's 1.96 on both sides. So that's how you do that. And we did that last time. Hopefully you guys have been practicing. And they show, once again, how to do this on the tables and all this. And this last time I showed you, I think, 3 common confidence intervals, alpha over 2s. Here are 4. And we want to calculate one more. I want to do one more just so everybody understands that these are the ones that are given for alpha over 2, but sometimes they don't give it to us and we have to figure it out. So if we have a normal curve, and let's say they say, hey, what's your Z value for an alpha over 2 of, let's see, we have these. Let's do one for, let's say, 80%. So if we want the middle 80%, that means there's 10% left on this side and 10% left on this side, and we have to find the Z value. And when you find a Z value, it's to the left using 552 at 10%. So let's try that on our calculator. Menu 552. And so we're putting in 10% now because we want to find this Z value, and we have to find the area to the left of that is 10%. So we put 0.10, except I think I typed in the wrong thing. Menu 55, I said 552, it's 553. The area is 0.10, 10%. So it should have been 553. I said 552, 553. There we go. And when we type in OK, it gives me a Z value of negative 1.28. So if I said, what's the Z alpha over 2 for 80%? The answer is 1.28. Okay, so you have to be able to do that because they don't always give you the correct or the alpha over 2. These are the most common ones used, but just in case on a test, they give you one that's not common. All right, so now we're going to do the actual confidence interval here. These are the steps we're going to be taking on the left, on the right. Finding a confidence interval. And so let's write down all the data we need. Let's see. It says a sample of 50 cars, N equals 50. Has a mean time on the lot. Mean is average of 54 days. So the average is 54 days. Population standard deviation is 6.0. And we want a confidence interval of 95%. So let's go to our calculator, create a new calculator page, go to menu 661, and see what we need to fill in. Menu 661. And I need to write this down because as soon as I leave, it's going to erase it. So let me write this stuff down. N is 50, X bar is 54, 6.0, and 95%. So if I go to my calculator and I go to menu 6, what did we say? 6, I think it's going to be 6. What did I say? 661?
Yes, one.
Okay, 661. It says, where do you want to get your data from? On my calculator, it says, hey, the Z interval, where do you want to get your data from? You're going to have to arrow over to that and type, click on stats. So we can get our data from a list, or we can get it, or we don't need the list. We get all the information. So on here, if you don't have a list, you click on stats and hit enter. And then, so stats is there, then I hit enter, and now it's asking for more information. It's asking for the population standard deviation, and we already said that was 6.0. Then it's asking for the average. Our average is 54 days on the lot. And then it's asking for N, the number of samples taken, and N was 50. And then the confidence interval was 95%. And so we put 0.95, that's already in there. When I hit enter, I have my confidence interval. My confidence interval is 52.3 and 55.66, which is 55.7. The lower and the upper limit are right here. This is the confidence interval, 52.3 and 55.7, if you round it to 1 decimal place. So I'm going to write that down and show us. So my confidence interval for this problem says, what is the confidence interval? The lower limit is 52.3. And the upper limit was 55.7. So this is how you write the confidence interval. That was one way of writing the confidence interval. Remember, you could also write the confidence interval like this. You have the mean, and 52.3 is on this side and 55.7 is on that side. This is another way of writing the same answer. And there's one more way of writing your confidence interval. If you remember, you write down the average. The average was 54. And then we plus or minus the margin of error. If 54 is right in the middle, then do you see it 1.7 to get larger? And if you subtract 1.7, you get smaller. So it's 54 plus or minus 1.7. There are 3 ways of writing this answer. All 3 of these ways are correct. You'll see that in the homework. It's probably easier. I think they just want you, when you write a confidence interval, they want you to do the top one. But from what we did last time, if you remember, this is the margin of error. This is the average, and you can add it and you get that, and you subtract the 1.7 and you get this. So this is the 3 different ways of writing the same answer. Normally in the homework, we would use the top one with parentheses around it like that. So let's try this again. Let's try another one. Large department store found that it averages 362 customers per hour. The average is 362. Standard deviation is 29.6. if a random sample of 40 hours was used, so N is 40. Do you see that's the sample, 40 hours they recorded, and then find the 99% confidence interval. So once again, we're going to go to 661 and type in this data. Six, 6, 1. It says Z interval. Make sure you don't have data. It should say stats. So it pops up and says Z interval. And I want you to select stats. If there's no list. Stats, if you don't have a list. And we're going to have a list later on, but I just wanted to show you right now. There's no list. We don't have any list that we typed in. There's no list of data here. So this is it. Hit enter. And then the standard deviation, once again, was 29.6. The list. Wait, I'm on the wrong. I think I might have typed. Did I type in the right thing? Menu 661. And we have to type in stats. There you go. Standard deviation was 29.6. The average on my calculator was 362. N is 40. And the confidence interval is 0.99. We have a 99% confidence interval. And when I hit enter on my calculator, hopefully your calculator also, if you're following along, lower limit is 349.94, so 349.9. The upper limit is 374.05, which is just 0.1. This is the answer to this problem, the confidence interval for this problem. It's a 90, I'm 99% certain our data is going to stay within this range, 349.9 to 374.1. I am 99% certain. So we're doing the 661 and then we're changing the Z interval to stats. Okay, and this is what happens when you need to type in the data, but I'm not typing in all this. I want to find a different problem. I think we have one down here. Here we go. I'm going to type this data in here. And I think this is the one on the other video. So first I need to type all this data into a list. Create a new calculator. It says data is used. So I'm going to type in a list page first. If you remember how to type in a list page, I'm going to do a new. And do you want to save? No. So remember, to do a list page, you go to 4 instead of add a calculator page. No, you're adding list and spreadsheet. Enter. I'm going to go up to the top at A and label it L1. L1. And then I'm going to start typing in the data. So I need to go back to the workbook. And then I'm just going to type in the data. And the data is 1.9, 3.2, and I'm going to type in all this data. 2.7, 2.9, 2, 2.8, 1.9, 4, 2.2. It's a lot of data. They could have came up with a smaller example. 2.7, 2.8, 3.2, 3, 3.8. Oh my. All right, so I typed in 25 pieces of data. My calculator says 25 pieces and I got 10 and 10 and 5. So I have 25 pieces of data. So typed in 25 pieces of data and labeled it L1. Now I need to go to 661. So I'm going to show my calculator. Once again, I typed in all my data there. I need to go to a calculator page now. So I need to create a new page, document, and add a calculator page. And there you see the 1.1 was my data, 1.2 is a calculator page, and we're going to go to menu 661. And this time we are going to use data because we have a list. It says use data or stats. We're going to keep it on data because we have a list. So if you have a list, you have to keep it on data. I hit enter. And let's see, I can't see this. So I'm coming back. And did it give us, oh, there's our standard. Do you see it gave us a population standard deviation of 0.62 in the problem. So 0.62. So the first one says, what's your standard deviation? 0.62. The second one says, what list are you using? And we're using, remember, I labeled it L1. So I'm going to, there's L1. I'm going to highlight L1. It's in there. Then it says your frequency is going to stay there. And right, yeah, frequency level, keep it at 1. Confidence level, I don't remember what they wanted us to do. Confidence level, I'm going to look right now. Confidence level is 94%. 94%. So I'm going to type in 0.94 and hit OK. And there's my confidence interval, lower and upper level. So let me write that down. So when you put this in your calculator, you should get a confidence interval 2.6 if we go 1 decimal place to 3.1. Yep. So this is the answer to this problem. And once again, this problem is on that other video there. So that's the confidence interval I get for this problem. If you have a list, you have to create the list first. And then in the Z interval, type in data. If you don't have a list, then you use the stats. But we did have a list, so you have to use data for the Z interval and then go 661. All righty. Something else we have to do in this section is find out how big a sample size we need. And this is the formula for how big a sample size we need. N equals the Z alpha over 2 times the standard deviation, all divided by the margin of error, right? That bottom, the big E is the margin of error. All right, so let's find out how big our sample size is going to be. Let's find a problem. Right, here's a problem. A scientist wishes to estimate the average depth of a river. He wants a 99% confidence interval. And an estimate confidence that is estimate is accurate within 2 feet. So this is really important. Accurate within 2 feet. That's the margin of error. They're giving you a margin of error of 2 feet. If you're accurate within 2 feet, you can be over 2 feet or under 2 feet, but within 2 feet. That's called the margin of error. And then standard deviation is this right here. So let's look at the formula again. N equals Z alpha over 2. I'm going to leave that blank for now. Times the standard deviation. We said that was 4.33 right there. And the margin of error we said was 2. So we need to find this Z alpha over 2 for what percentage did we say? It's, where's the percentage?
99%.
99%. So go back to our workbook on the most common. 99% should be one of those most common. If we go back up there. There it is. 99% is 2.58. 2.58. So I'm coming back. So I put 2.58 in here. And oh, wait. By the way, the formula is wrong. Let me show you what happened. Somehow when they did the publishing, the formula ended up being wrong when they printed this out. This is the problem. But this formula, so everybody needs it on your workbook, change it. This should be squared. There should be a square symbol. N equals Z alpha over 2 times standard deviation divided by the margin of error squared. So you have to add a power of 2 to that N. So we're going to put a power of 2 into this. So I'm going to put this in my calculator on my calculator page. I'm going 2.58 times 4.33 divided by 2. I hit enter, and then I raise it to the second power. I square it, raise it to the second power. And when I put that in my calculator, I get 31.2. So that's what you should get. 2.58 times 4.33 divided by 2, hit enter, and then raise it to the second power, then square it, and you get 31.2. Now, for margin, for this N, for N, we got 31.2. However, if there's any decimal, we round it up. We don't just round it, we round it up. So if there's any portion of the decimal still here, you have to go to the next whole number for N, to find N. So since there is some, even though it's not 5 or more, but just any decimal left over in the N problems, you take it to the next higher whole number. If it was 0 there, then you wouldn't take it to the next higher whole number. But any decimal other than any part decimal other than 0, you need to take it to the next whole number. So it says how large of a sample is required. Our sample requires 32 people or 32 samples taken, whatever the N is.
Professor, I have a question.
Yes, sure.
Where did you find the 2.58?
Up in the most common parts. I scroll up where we said it. We showed it earlier. I'm going up. Going up, the most common, oh, we passed it. Right here. See, these are the common confidence intervals. And we had 99% confidence interval. So we use a Z alpha over 2 of 2.58 on page 218 of the workbook.
Thank you.
So once again, those are the most common ones that, and so that's why they leave them there, and you can use those to do that. So this was that, and let's see what this next problem is. So this is the same type of problem. So let's do this N also. Don't forget the formula for N was the Z alpha over 2 times standard deviation over the margin of error squared. It says if the variance of a national accounting exam is 930. Uh-oh, this is going to be a good one. If the variance is 930, how large must the sample size be? That's why we're looking for N. True mean score within 5 points. Within 5 points means the error is 5. We're 5 points above or 5 points below. And then we need to find the 90% Z value for alpha over 2. So if we go back up to the most common and look at the 90%, 90% is 1.65, if you see that there. Right here. Oh, I can't even write. 90% is 1.65. So in our problem, I'm going to put 1.65 here. Our variance, our margin of error was 5. I'm going to put a 5 here. And we have to fill in this spot. Let me go back down. So can somebody tell me what number I put in for right here? That's the only thing I'm missing. Anybody know how to find that? What does this represent? What's variance? What does variance mean? Remember, population variance is this symbol squared. This is standard deviation, but variance is standard deviation squared. So we need to find, we know this variance.
The square root of
Yeah,
930?
on your calculator, take the square root of 930. So this equals the square root of 930. So you want to take the square root of both sides. So on your calculator, take the square root of 930. Yes. 900 and, well, let me hit square root.
I got 30.4959.
30.49. And we're going to go to one decimal place, 30.5 then. So we put a 30.5 here. So this equals 30.5. So on our calculator, we're going to do 1.65 times 30.5 divided by the margin of error of 5. And then we're going to square the whole thing. So let's try that. .65 times 30.5 divided by 5. And then you got to square the whole thing.
I got 101.304.
And that's what I got. N equals 101.304. So what N do I use? What's my answer?
102.
Yes, any decimal that's left over goes to the next higher whole number. So the answer to this problem is 102. Good. All right. And I think that's the section, but I do want to go to the homework and just look at a couple of things in the homework. Give me a second. Yeah, that was it. So we're doing the confidence interval when we don't have a list. We're doing the confidence interval when we have a list, and then we're going to find N. Those are the three things we're doing in this section. So let me get to the homework. See if I can even find the homework page. Hang on, I got so much stuff on this. Let's go to the homework. And we are on 7.2, right? Yeah, 7.2. Number one is just those common Z alpha over 2s. Oh, this was a good one. I talked about this last time, but they didn't really mention it too much here. A sample of 55 retired men, the average number of jobs they had during the lifetime was 7.2. The population standard deviation is 2.3. Find the best point estimate for the mean. Anybody know the answer to this? I talked about it last time. The best point estimate for the mean is the mean, the population mean. I think the answer is just 7.2. So let's type 7.2 into here. And we got the right answer. So once again, we talked about that. What was I mentioned that last time. The best point estimate is normally the population mean, and the lifetime was 7.2. That was the mean. The average number of jobs was 7.2. That is the best point estimate, which is the same thing as population mean. Now find the 90% confidence interval. So we're going to do that. We want 90% confidence interval. Our mean is 2.3. We have a sample of 55, N is 55. First of all, standard deviation was 2.3. And this was 7.2. The average was 7.2. Average was 7.2. Standard deviation is 2.3. And N is 55. 7.2. And we're going to go to 661. And don't forget, for our Z, we're going to go to stats because there's no list. So we're going to do turn it on, go to a calculator page and do menu 661. And your data input method for Z interval should go to stats. Our standard deviation is 2.3. Our average was 7.2. Our N is 55, and our confidence interval was 90%, 0.90. And this is my confidence interval, 1 decimal place, it says. So my confidence interval, 1 decimal place is 6.7 to 7.7. So this is what I got. $6.7 to 7.7. Let's check that. If it lets me. And we got it correct. Then it asks you to find the 99% confidence interval. You have everything typed in there. It's all the same data except change it to 99%. So, I mean, nothing new. Menu 661, keep it on stats, put it on stats. Standard deviation was 2.3. Average was 7.2. N is 55 and confidence level is 0.99. And this time I get 6.4. And the upper limit is 8.0 if I round it to 1 decimal place. And we got that correct also. Okay. All right, let's move on to the next question. Question 3. Let's take a look. God, I really don't want to type in all this data. Let me see if there's any that have a smaller amount of data. 4, 5. They all have pretty good amount of data. Okay, let's do 4. Let's do 4. So I'm going to type all this data into list 1. So I'm going to create a list page. So I got to start over, new document and everything. And I'm going to start a list page. List page is 4, remember. Turn it on and then click on 4. Label your list A, up in A, I'm labeling mine L1. And then you got to type in all this data. Good luck. Hopefully I don't mess anything up. You got to be really meticulous or it's so easy to mess up a number. All right, so I typed in all my data, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 25 pieces. I have 25 pieces. So I typed all my data in. We want 99% confidence interval. In the problem, it says, hey, give me a 99% confidence interval. There's my standard deviation. So I'm gonna go to, I gotta go to a new page. I gotta create a calculator page, control doc, calculator page. And then I'm gonna go to menu 661. But this time, menu 661, this time you have to change data. Oh no, you keep it as data. You don't want it on stats. Anytime you have a list, you keep it on data. So I'm just gonna hit enter and keep it on data. My standard deviation, now I'm gonna go back to see what we had there. Standard deviation was 31. The list is L1. My list was L1. Frequency list stays the same. And then my confidence interval is 0.99.
Sir,
Yes,
I'm sorry,
Paul.
what was the frequency list supposed to be? Because mine was on L1.
Frequency list just on one.
When I'm looking at mine, all I see is L1 stat dot C
Hang on.
lowers.
Give me a second. Wait, let me bring up my calculator. Okay, so let me escape. Let's try this again. Menu 661. Oh, sorry. So this needs to be on data, right?
Yes, sir.
Okay, so then here, standard deviation. What was standard deviation again? I'm sorry.
31.
31. The list, are you saying the list had the frequency has to stay on one right there? You can just type in a one, but list has to be your L1, whatever you labeled your list as. I labeled mine as L1.
Oh, yes, sir. My frequency list had changed to L1, so I wasn't
Okay.
sure.
All right, yeah, no, so if you have anything other than this, just type in a one in there, just put a one in there. In the frequency
sir.
list, okay. And then this, what do we say, 99%, 0.99?
Yes, sir.
Okay, and then that's what we should get then. So let's see what I got here. I got lower limit 30.9. That's if I typed in the data correctly. And the upper limit, I got 62.9.
Sir, if we round to 1 decimal, then it would be 31 because it's 30.95.
No, it's 30.94. Yours says 95?
Yes, sir. Mine
Okay.
says 30.956 or 9536.
Okay, maybe I typed in the wrong data then. Let me check my answer real quick. Okay, mine's okay. So maybe one of your numbers is off a little bit because mine says 30.9499.
Yes, sir. I probably just entered one of the numbers wrong.
Yeah, I mean, even if you put 30, try to put 31 in there and see if they take it. They might be a little margin of error and they might take it. Oh, well, you would have a different problem than me if you were in the homework, because each person generates a different homework problem. So, I mean, you could check your data and see if you're off of like one number or something like that. So that's if you have a list, you have to put it in the list first, and then you have to label that list and put it on there. And this is what I got. All right, so we'll do one more problem, finding n, I think. Let's see what we have. How large a sample size do we need? Okay, so this is finding n, and I'm going to write down the formula first. N equals z alpha over 2 times standard deviation over the margin of error squared. 95%, we have to find that. Standard deviation is 41. And the margin of error, population mean, is within 9 minutes. So the margin of error is 9. So we need to find the Z alpha over 2 for 95%. Can somebody look that up and tell me what it is? Anybody have their workbook? Right there. No,
1.96.
Thank you, thank you, thank you. Because if I go back to the workbook, it's gonna delete all this stuff that I'm writing down. So this is what we want to type into our calculator. 1.96 times 41 divided by 9, and then square it all. 1.96 times 41 divided by 9, and then raise it to the second power. And I get 79.7. And you always take it to the next higher whole number. So we should have, we need a sample of at least 80 people. That's it. All right, that's all I had for the day. I'll hang around if anybody has any questions. Let me know if you need anything. Once again,